The last section in the special theory of relativity is on the Lorentz transformation itself. This is section 37.5, and it's somewhat more advanced. I'm going to put it in here for those who are interested. I normally do not test on this material in the 201, 202 level. You have to really know some matrix theory to understand this, but it says that the vector x in a primed frame is equal to a linear transformation or matrix times the vector in an unprimed frame. So if we have two frames, let's call this one x. This is Bob, who's just sitting here on the ground, and Jack is moving by at some velocity capital V, and he has x prime, he'll have t prime, and this guy has x and he has t, to measure events that happen out here, like a firecracker goes off. And they're looking at the position and the time when this occurs. This transformation, called the Lorentz transformation, is the foundation of the theory of special relativity. And in this transformation, like I write out here, x is now a vector in 4 dimensions, made up of ct, x, y, and z. This is often called x0, x1, x2, and x3, because we get tired of using up so many different letters. So we call the naught component, the 0th portion, the 4th dimension. So this gives us our x. And now you can see that if we write this out, this becomes what is called a 4x4 transformation between a vector that would look like x0, x1, x2, and x3. This is x right here. And so there'd be 4 parts of this, so this matrix here would have 4x4 entries. And I'm going to simplify it by forgetting about y and z and only looking at the x direction with time. And if I do that, this becomes 2-dimensional, and I get x prime, which is x0 prime, and x1 prime. This is to the moving guy, and that's going to equal to a matrix times x0 and x1, the time and the position for the guy who's sitting on the ground. You remember this x0 is actually c times t. The reason for that is we're going to take all of his clocks and multiply the time on those clocks in seconds by the speed of light, and that will give us a velocity times the time. It is measuring our time in units of meters. That's because these two things are going to mix up, and we couldn't put time here because time can't mix up with a meter. We have to mix things that are only the same units, you recall. So the question is, what are these 4 terms? How are these made? Well, this is a more advanced topic, and it turns out that this matrix is represented by hyperbolic functions, ch psi, sh psi, sh psi, and ch psi, where sh is equal to the hyperbolic sine of an angle, and ch psi is the hyperbolic cosine of the angle. These are just nicer short abbreviations for these. They're very similar to sines and cosines, but they're the hyperbolic versions. And so it turns out that the psi is such that the tangent of psi is equal to v over c. So this is dependent upon the speed with respect to the speed of light. Now, this has to be something that is dimensionless because it's the argument of a transcendental function. Therefore, it would have to be of the form v over c, and that says what fraction of that is. And you'll recall, if you remember your hyperbolic functions, that ch psi squared minus sh squared psi is equal to 1. But for regular functions, the cosine squared of theta plus the sine squared theta is equal to 1. So this difference in sign here makes the difference between automatic or regular trigonometric functions, which relate to a circle, as I'm rotating around in a circle. And I would rotate it in a circle if these were cosine, sine, sine, and cosine. And that's how we rotate in a circle. But these movements are movements along hyperbola. These hyperbola look like this. So rather than being motions on a circle, they're motions on a hyperbola with respect to x and t. And when you do those motions, you get the Lorentz contraction and the time dilation. Well, I'm not going to go further into this. This is the more formal aspect of looking at what is called the Lorentz transformation. Those of you who study more advanced physics will learn that this constitutes part of a group of transformations that take us from one observer to another one. And it's a symmetry transformation. It's actually generated by something called a Lie algebra. And this whole study of symmetry in physics is of the deepest importance, as we'll see later on.